Assalamu alaikum. How are you, students? Hope you all are fine. I'm also fine. Today I'm here to take class for standard 11 and 12. So welcome back to my physics class. Dear student, here is my identification. Me Mafru Shati, lecturer of Physics Square High School and College, Pabna. I have already started your new chapter, that is Thermodynamics, and that is the first chapter of your physics second paper. So today I will explain some topics from thermodynamics. Especially I will explain different thermodynamic processes. So let's start the class. Thermodynamic process. Dear student, you are well known with system. What is system? System means the things with what we do any work. That is known as the system. And the things around itself is known as surrounding. So any change of system is known as thermodynamic process. There are 4 types of thermodynamic process: isobaric, isochoric, isothermal, and adiabatic. So let's explain at first isobaric process. Isobaric process, the thermodynamic process in which the pressure of the system is not changed, is known as isobaric process. Look here, isobaric. Iso means same and bar means pressure. So same pressure. If same pressure is maintained in a system, that system is known as, that change is known as isobaric process. The heat transferred to the system does work, but also changes the internal energy of the system. Look at this graph. So here pressure remains constant. That means at point A the pressure is P, and at point B also the pressure is P. So you get a horizontal line that represents there is no change of pressure. Pressure remains constant. But look here, at point A the volume which is plotted in the x-axis is VA, and the volume at point B is VB. So here the volume is changed, that means volume is increasing. So work is done, and this work can be calculated by this area, the area below this line AB. Okay, and you know area equal to what? Length into breadth. So here P represents the length, and del V, that is the change of volume, represents the breadth. So by multiplying these two, we can calculate the work done. So del W equal to P del V. Here del V represents the change of volume. So change of volume del V equal to VB minus VA. So from first law of thermodynamics, you know first law of thermodynamics states what? Del Q equal to del U plus del W. So in place of del W we can write P del V. So it means what? It means the supplied heat is used to increase internal energy and to perform external work done. Look here in this figure, the pressure is maintaining constant. Look at this indicator, pressure is constant. But the volume is changed. As a result, temperature is also changed. Look here, volume is changed and temperature is also changed. So if temperature is changed, then internal energy also will be changed. Temperature increased, then internal energy will be increased. Temperature decreased, then internal energy also will be decreased. So here we can get that the heat supplied to the system, here heat is supplied to the system, so that heat is taken to be positive, because you have to remember one thing: when heat is supplied to the system for doing any work, heat should be supplied to the system, otherwise work cannot be done. Another way work can be done if system loses heat. So generally heat should be given to the system for doing any work. That's why this del Q will be positive. Now we will explain isobaric process by using an animation. Look at the animation. So here you get, by applying heat, the volume is changed, the temperature is changed, and the pressure remains constant. So now I will explain another thermodynamic process, that is isobaric process. Isobaric. An isobaric process also called a constant volume process, an isovolumetric process, or an isometric process, is a thermodynamic process during which the volume of the system remains constant. Look here, the volume remains constant but pressure is changing. Look, at point A the pressure is PA, and at point B the pressure is PB. So by using this vertical line, we can understand that pressure is changing from A to B, but the volume remains constant, that is V. So here work done will be what? As there is no change of volume, so no external work is done. That means del W equal to P del V. Del V is 0 because initial volume and final volume is same. So del V, that is the change of volume, will be what? 0. And if del V is 0, then work done will be 0. So first law of thermodynamics can be rewrite here, that is del Q equal to del U plus del W. So by putting the value of del W equal to 0, we get del Q equal to del U. That means what? That means increase of internal energy is equal to the supplied heat energy. I think you understood. So isobaric process, I will again summarize that constant volume, and its another name is isovolumetric. You should know this another name, alternative name, because in MCQ you may have this alternative option. Change of pressure and temperature at constant volume. You know, thermodynamic coordinates, there are three thermodynamic coordinates: pressure, volume, and temperature. So if any of the coordinate is constant, then other two will be changed. So here volume remains constant, but pressure and temperature is changing. With constant volume there is no movement, so no work is done. That means work equal to 0. Look, initially the pressure is P1 and Pi, and after applying supplying Q amount of heat, the pressure becomes PF. So here pressure is changing from Pi to PF, but the volume is constant. So as there is no change of volume, so work done equal to 0. And so in isobaric process we get that the heat supplied to the system is used to increase the internal energy. So again there is an animation. There is an animation for you which will make you more clear about isobaric process. Look here, in isobaric process, heat is supplied to the system and the pressure is increasing, volume remains constant, and temperature is changed. Now I will explain another thermodynamic process, that is isothermal process. So let's look. Isothermal process. An isothermal process is a thermodynamic process in which the temperature of a system remains constant. The transfer of heat into or out of the system happens so slowly that thermal equilibrium is maintained. Look, here the system undergoes isothermal process. Heat is supplied to the system. As a result, pressure and volume is changed, but the temperature remains constant. So U is proportional to T, that is Mayer's hypothesis. That means internal energy is proportional to temperature. So as temperature is constant, so change in internal energy del U equal to 0. That internal energy is proportional to the temperature. That means when temperature is increasing, internal energy also will be increasing. Temperature if decreased, then internal energy also will be decreased. But there is no change of temperature. Temperature is constant. So del U will be 0. That means first law of thermodynamics can be written del Q equal to del U plus del W. Here del U equal to 0. That means change in internal energy will be 0. So del Q equal to del W. What does it mean? That means in isothermal process, work done by the system is equal to the heat supplied or absorbed by the system. Look, here in the container there is some gaseous substance and heat is supplied to the system, but here heat given to the system very slowly, and the gas which is contained in a container, that container is made of good conducting material, so that it can conduct the heat very easily. So here think about it, how does this is occurring. That means isothermal process is happened occurring here. That is, heat is supplied to the system, but temperature is not changed. So that heat is used to change the volume. That means what? The system does what? Here volume is increasing. That means system does what? So suppose if the supplied heat is used to increase internal energy, then what will happen? If internal energy is increased, then suddenly temperature will be fallen down. Temperature will fall down. So if temperature falls, then what happens? Then temperature will not remain constant, but our aim is to keep the temperature constant. Actually, isothermal process, it is an imaginary process. In practical life, this type of process is not existed, because total amount of heat will be converted into work done. It is not possible actually. But so to perform this experiment, we have to supply heat very slowly, and if it happens like when internal energy is increased, then temperature falls. So at that time, as it is made of good insulating, good conducting material, so it conducts heat from the surrounding, and again temperature becomes T. That is the previous temperature. In this way, temperature should maintain constant. And look here, temperature is constant, pressure is decreasing, and volume is increasing. So this is isothermal process. But this, you have to remember one thing, in this process, the process is very slow, and the system should be made of good conducting material. Again, I want to summarize isothermal process. So an isothermal process is a constant temperature process. Any heat flow into or out of the system must be slow enough to maintain thermal equilibrium. For ideal gases, if del T is 0, then del U equal to 0. Therefore, Q equal to W. That means what amount of heat will be supplied to the system, that will be converted into work done totally. Now, very interesting process, that is adiabatic process. Adiabatic process. Here, look at this word. A means no, dia means through, bets means heat. So in a single word, adiabatic means heat not passing through. That means heat neither enters into the system nor the system rejects heat. An adiabatic process occurs without transferring heat or mass between a thermodynamic system and its surroundings. Unlike an isothermal process, an adiabatic process transfers energy to the surroundings only as work. In adiabatic process, heat is not exchanged, so del Q equal to 0. So del Q equal to, we get from first law, del U plus del W. As del Q equal to 0, so we get del U equal to minus del W, or del W equal to, can be written minus del U. So here you are seeing heat is not supplied to the system, or the system doesn't reject any heat to the surrounding. That means there is no exchange of heat here. So del Q equal to 0. So, but the system is doing what? Doing external work. How does it happen? That means the system does work by using its internal energy. It is, I can give you one interesting example. Suppose I am not serving you any food, but I have told you to do physical exercise. And how can you do physical exercise? At that time, you should use your internal energy to perform the physical exercise. The energy which is stored in your body. Like this, like that, this is happening here. That means heat is not supplied to the system, but the system does work by using its internal energy. That's why del W, when del W will be minus del U, that means internal energy will be decreased. So when a gas is suddenly compressed, then an amount of heat is produced. Think about it. When a gas is suddenly compressed, then an amount of heat is produced. If this heat is not removed, then the temperature of the gas will increase. Again, when a gas is suddenly allowed to expand, the gas will lose some amount of heat. So if equal amount of heat is not supplied from outside, the temperature will decrease. So in this change, temperature never remains constant. Here temperature is changed, but heat is not supplied. Furthermore, it is mentioned that in this case, the gas neither receives heat nor reject heat, but internal energy of the gas doesn't remain constant. Increase or decrease of internal energy takes place, because here the temperature doesn't remain constant. That's why internal energy also will not be constant. Internal energy will be changing. Either it will be increased or it will be decreased. So in adiabatic process, work done by the system is executed by the internal energy of the system. And you have to remember one thing. Change of pressure and volume of a gas by keeping the total amount of the gas constant is called adiabatic change. In this change, temperature changes. It is very fast process. You have to remember this information, because in MCQ frequently it comes. Adiabatic process is slow process or fast process. Isothermal process is slow or fast. This type of question always comes. It is very fast process. In this change, the container should be made of bad conductor, because heat doesn't pass through. That means the container should be made of bad conductor or insulating material, so that heat cannot pass from surrounding to the system or system to the surrounding. Thermal capacity of the surrounding should be low. So here Q equal to 0. So this is achieved by thermally insulating the walls of the system and having the process proceed so quickly that no heat can be exchanged. I want to summarize again adiabatic process. It can be accomplished by thermally insulating the chamber, performing the process very rapidly. No time for heat to be transferred. You have to remember. Why it is very rapid? Because no time for heat to be transferred. If we do work to compress the gas, the temperature of the gas should increase. The increase in the temperature of the gas corresponds to an increase in the internal energy of the system. That's why here internal energy of the system will be changed. Example, expansion of hot gases in an internal combustion engine, liquefaction of gases in a cooling system. So this is a special case of an adiabatic process, adiabatic free expansion, where the gas expands into free space. Look here. Here, no heat is supplied. Look, there is no source of supplying heat, but the volume is changed. Volume is increasing by using the internal energy. Volume is changed. That means what? The system does work. Here, system does work by using its internal energy. I think you understood it. Now, there is a chart for you which is very important. That means you have to remember which things remain constant in different thermodynamic process. Isothermal process. Here, temperature remains constant, and that's why del U equal to 0. So, the heat supply to the system will be converted into work done, Q equal to W. Isovolumetric or isochoric process. I have told you earlier that isovolumetric or isometric are the other name of isochoric process. Here, volume constant, work done equal to 0. As there is no change of volume, so work done is 0, and del U equal to Q. That means the heat supplied to the system will be used to change the internal energy. Isobaric. By seeing the name, you understood. Here, which thing is constant? Pressure is constant. Del U equal to Q plus P del V. Adiabatic. Nothing is constant. You have to remember one thing. In adiabatic process, nothing is constant. Here, heat is not supplied to the system. Okay. Heat equal to 0. Look here, in this case, temperature at a certain temperature, one certain temperature should be maintained, which is constant, certain volume, certain pressure, but here Q equal to 0, that means it is not constant. So del U equal to minus del W, or work done. That means work is done by using the internal energy. Dear student, I think you have understood different thermodynamic process very nicely, because I tried to explain in the simplest manner. So you have to read the book and you should try to solve the MCQ. Today I am to finish my lecture. In the next class, I will explain some interesting topic like entropy. So till then, stay safe. There is a moral for you. Thank you for watching my content. Goodbye.